In computer networking, a port is an application-specific or process-specific software construct serving as a communications endpoint in a computer's host operating system. The purpose of ports is to uniquely identify different applications or processes running on a single computer and thereby enable them to share a single physical connection to a packet-switched network like the Internet. In the context of the Internet Protocol, a port is associated with an IP address of the host, as well as the type of protocol used for communication. The protocols that primarily use ports are the transport layer protocols, such as the Transmission Control Protocol and the User Datagram Protocol of the Internet Protocol Suite. A port is identified for each address and protocol by a 16-bit number, commonly known as the port number. The port number, added to a computer's IP address, completes the destination address for a communications session. That is, data packets are routed across the network to a specific destination IP address, and then, upon reaching the destination computer, are further routed to the specific process bound to the destination port number. Note that it is the combination of IP address and port number together that must be globally unique. Thus, different IP addresses or protocols may use the same port number for communication. For example, on a given host or interface UDP and TCP may use the same port number, or on a host with two interfaces, both addresses may be associated with a port having the same number. Of the thousands of enumerated ports, about 250 well-known ports are reserved by convention to identify specific service types on a host. In the client-server model of application architecture, ports are used to provide a multiplexing service on each server-side port number that network clients connect to for service initiation, after which communication can be re-established on other connection-specific port numbers. Technical details: transport layer protocols, such as the Transmission Control Protocol and the User Datagram Protocol, specify a source and destination port number and their packet headers. A port number is a 16-bit unsigned integer, thus ranging from 1 to 65,535. A process associates its input or output channels via Internet sockets, a type of file descriptor, with a transport protocol, a port number and an IP address. This process is known as binding, and enables sending and receiving data via the network. The operating system's networking software has the task of transmitting outgoing data from all application ports onto the network, and forwarding arriving network packets to a process by matching the packet's IP address and port number. Only one process may bind to a specific IP address and port combination using the same transport protocol. Common application failures, sometimes called port conflicts, occur when multiple programs attempt to bind to the same port numbers on the same IP address using the same protocol. Applications implementing common services often use specifically reserved, well-known ports for receiving service requests from client hosts. This process is known as listening and involves the receipt of a request on the well-known port and establishing a one-to-one server-client connection, using the same local port number. Other clients may continue to connect to the listening port. This works because a TCP connection is identified by the tuple local address, local port, remote address, remote port. The well-known ports are defined by convention overseen by the Internet Assigned Numbers Authority. The core network services, such as the World Wide Web, typically use small port numbers less than 1024. In many operating systems, special privileges are required for applications to bind to these ports, because these are often deemed critical to the operation of IP networks. Conversely, the client end of a connection typically uses a high port number allocated for short-term use, therefore called an ephemeral port. The port numbers are encoded in the transport protocol packet header, and they can be readily interpreted not only by the sending and receiving computers, but also by other components of the networking infrastructure. In particular, firewalls are commonly configured to differentiate between packets based on their source or destination port numbers. Port forwarding is an example application of this. The practice of attempting to connect to a range of ports in sequence on a single computer is commonly known as port scanning. This is usually associated either with malicious cracking attempts or with network administrators looking for possible vulnerabilities to help prevent such attacks. Port connection attempts are frequently monitored and logged by computers. The technique of port knocking uses a series of port connections from a client computer to enable a server connection. Examples: an example for the use of ports is the Internet Mail System. A server used for sending and receiving email generally needs two services. The first service is used to transport email to and from other servers. This is accomplished with the simple mail transfer protocol. The SMTP service application usually listens on TCP port 25 for incoming requests. The second service is usually either the Post Office Protocol or the Internet Message Access Protocol, which is used by email client applications on users' personal computers to fetch email messages from the server. The POP service listens on TCP port number 110. Both services may be running on the same host computer, in which case the port number distinguishes the service that was requested by a remote computer, be it a user's computer or another mail server. While the listening port number of a server is well defined, the client's port number is often chosen from the dynamic port range. In some applications, the clients and the server each use specific port numbers assigned by the IANA. A good example of this is DHCP, in which the client always uses UDP port 68 and the server always uses UDP port 67. Use and URLs. Port numbers can occasionally be seen in a web or other service uniform resource locator. By default, HTTP uses port 80 and HTTPS uses port 443, but a URL like HTTP www.example.com 8080 specifies that the web resource be served by the HTTP server on port 8080. The active transport layer protocol ports may be discovered on many operating systems with the command line netstat-a. Common port numbers. The Internet Assigned Numbers Authority is responsible for the global coordination of the DNS route, IP addressing, and other Internet protocol resources. This includes the registration of commonly used port numbers for well-known Internet services. The port numbers are divided into three ranges: the well-known ports, the registered ports, and the dynamic or private ports. The well-known ports are those from 0 through 1023. The requirements for new assignments in this range are more strict than for other registrations. Examples include 20 and 21, File Transfer Protocol, 22. Secure Shell, 23, Telnet Remote Login Service, 25, Simple Mail Transfer Protocol, 53, Domain Name System Service, 80, Hypertext Transfer Protocol used in the World Wide Web, 110, Post Office Protocol, 119, Network News Transfer Protocol, 143, Internet Message Access Protocol, 161, Simple Network Management Protocol, 194, Internet Relay Chat, 443, HTTP Secure, 465, SMTP Secure. The registered ports are those from 1024 through 49151. IANA maintains the official list of both ranges. The dynamic or private ports are those from 49152 through 65535. One common use is for ephemeral ports. History. The concept of port numbers was established by the early developers of the ARPANET in informal cooperation of software authors and system administrators. The term port number was not yet used at this time. It was preceded by the use of the term socket number in the early development stages of the network. A socket number for a remote host was a 40-bit quantity. The first 32 bits were similar to today's IPv4 address, but at the time the most significant 8 bits were the host number. The least significant portion of the socket number was an entity called another 8-bit number, abbreviated AEN, today's port number. On March 26, 1972, Vint Cerf and John Postal called for documenting the then current usages and establishing a socket number catalog in RFC 322. Network administrators were asked to submit a note or place a phone call, describing the function and socket numbers of network service programs at each host. This catalog was subsequently published as RFC 433 in December 1972 and included a list of hosts and their port numbers and the corresponding function used at each host in the network. This first registry function served primarily as documentation of usage and indicated that port number usage was conflicting between some hosts for useful public services. The document promised a resolution of the conflicts based on a standard that Postal had published in May 1972 in RFC 349, in which he first proposed official assignments of port numbers to network services and suggested a dedicated administrative function, which he called a ZAR, to maintain a registry. The 256 values of the AEN were divided into the following ranges: 0 through 63, network-wide standard functions, 64 through 127, host-specific functions, 128 through 239, reserved for future use, 240 through 255, any experimental function. The Telnet service received the first official assignment of the value 1. In detail, the first set of assignments was 1 Telnet, 3 file transfer, 5 remote job entry, 7 echo, 9 discard. In the early ARPANET, the AEN was also called a socket name, and was used with the initial connection protocol, a component of the network control program. NCP was the forerunner of the modern Internet protocols. Today the terminology service name is still closely connected with port numbers, the former being text strings used in some network functions to represent a numerical port number. See also, Stream Control Transmission Protocol, references.